Hi Engineering Janta, I am Vaibhav Shukla and today we'll be understanding the implementation of linked list. This is another free video in the free DSA series that we're building for you so that you thrive high in your career. I know it's been a long time and it's been a very long time since we have worked on this series, so I'm back with it again. And a quick recap of linked list if I give you. All of you by now have seen my videos, and if you haven't seen, go ahead, watch those videos first. So this is how a linked list looks like. Fine, a very small linked list I am making. So if this is head, this will point to this node, data would be here, then next pointer, and then another data, and then null, right? So in such manner you find your linked list, right? So today we'll understand how it is implemented. Let's straight away dive into the code portion of it. Okay, so if I talk about the code portion of it, I declare a class node. Fine, I'm using the class method to implement it. I'll suggest you must explore various other methods possible. Fine, and all these methods are available on Prep Insta Prime. I'll tell you where you can find them on Prime, but right now focus here. So if you focus here and if you try, see, this is a class node. Fine, I have created a class named node, and in this I have declared two things. One is integer type data it can hold, and a pointer which will point to the next node. Fine, then I create another class called linked list. In this I give it a private basically section of node pointer where a pointer is head. Fine, this is access specifier. So this access specifier says that only in this class this pointer head can be accessed. This pointer is of this type. Fine, so basically this pointer will point to a structure which is of this particular type. Fine, now using the constructor in itself, I initialize head to null. Fine, initially I create a node and here I initialize it with null. Basically it is pointing nowhere. Fine, why did I initialize it like this? The reason being, I need to have a starting point, right, of head. So this is the starting point. Right now it is not pointing anywhere. Right now it is not pointing to any node because there is no node existing. Right now the linked list is empty. We are not having any nodes. Secondly, why did I use constructor to do this? The reason for that was I declared it under the private access specifier. People call it accessifier, people call it access specifier, people call it access modifier. Fine, so I declared it under the private access modifier, right? So in this private access modifier, what I did was I declared a pointer, fine, of node type which was pointing to actually a head that is generally an initial pointer that we have in a linked list. But if you carefully see, I cannot access it outside this class. I cannot go outside this class and simply change its value. I can only access it inside this class using a constructor, right? So using a constructor, I accessed it and initialized it to null. Now when I move further, I declare a few methods or few functions that I'll be using. All these functions like calc size, insert start, insert last, insert position, display, we'll understand how these functions are actually working. But here, what will calc size do? Calc size will calculate my exact size of the particular linked list that we are trying to deliver. Alongside that, we have insert start, we have insert last, we have insert position. All these by name are clear that insert start will function in a manner where we'll be trying to insert an element in the start of the linked list. For example, we have 3 nodes. So after the head, immediately I'll be trying to insert one particular node. Fine, in this start itself, I'll be trying to insert the node. And in the last, I'll be inserting it in the very last of the linked list. Fine, for that insert last. And if I want to insert somewhere in the middle after some particular node, for that I would use insert position, and then display would be used to see the linked list. Fine. So we'll come to calc size later. First we'll understand the insert start. The reason being, right now your linked list is not having any nodes, it is not having any size. So how would you calculate it, right? So let's go further and let's first of all insert a few elements. So what you can do is, as I told you, any linked list is nothing but a collection of nodes, right? Like this, right? Like this, any linked list is a collection of nodes. Now in this case, what I do is, I declare this, I had already declared this function, now I am defining this insert start. So this takes int data as some input, fine. So for that, say I want 50 as my data, which would be stored here, and then a pointer would be stored for the further next node. So what I'll do is, I create another pointer again of node type, so new node, and here basically I am declaring a new object of node class, fine. With this I get basically this structure where I can store data and I can store a pointer. Then in the new node I'll point to the data section, fine. In that data section I'll store this data, basically this int data would be stored here. So if this was head, fine, I initialize some new node right now, fine. In this new node, let's name it new node, fine. So in this new node, in this data portion, I'll store 50 from this particular line of code. I'll store 50 here, and then what I'm doing is, in the next pointer, basically I'm trying to store the head, fine. Basically the head, whatever I had, the value in the head, I am assigning it to the new node next. So basically head was null initially, so here it would be assigned null, right? And the head would start pointing to the new node. So this was head. Now earlier it had null value, right? If you carefully see, our head had null value. This was the head that we initialized, right? So after this head, what we are trying to do is, we initialized a new node, we put the value of head into the next section of this new node, right? And then what we did was, we updated the head with the pointer that points to the new node. So basically now this starts pointing to the new node, fine. Now I want to insert another particular value into this linked list. So basically I want another node. So for that I'll say 40 is the new data that I want to insert. Now in this case again similar structure I'll develop. So similar node, and this, let's remove this now, and let's name this particular node as new node, fine. Data is 40, new node points to a particular data, a data portion is there in the new node. Why is it there? See, it is there because of this particular class. You have a data variable, fine. Now when you point to this particular data variable, you're trying to say that the structure that we have here, new node, has a data variable inside it. In that, store this particular data, fine. So when I tried storing this, it will basically store 40 here, and then head had the value of this particular node, right? Head had the value of this particular node, right? It was pointing to this, let's say it was some PTR, some pointer that was pointing to this particular node. Now I am inserting in start. So basically I'll push my new node here, which basically means that first node should be this and second node should be this. So what I'll do is, I'll update this in a manner that whatever value is present in head should be assigned to the next of this new node. So this pointer should basically be assigned to this particular place, fine. So I'll assign PTR here, fine, and this starts pointing to this node. Now head starts pointing to the new node. This is new node now. So this particular head I update it in such a manner that it starts pointing here, right? So now if you see, linked list has been modified, the insertion at start has taken place. Earlier this was my first node, now this is my first node. Now earlier head was pointing to this particular node, now head is pointing to this particular node, fine. So I guess that's clear in the insert start. If you have any doubts, you can comment out, and there is a benefit of commenting out in this video. Below this video I'll go ahead, I'll explain that to you as well, don't worry, fine. So let's come back to the calc size. Let's calculate the size now, because we have two nodes in our linked list, right? So what I'll do here is, I'll initialize another structure Here actually we tried initializing a new node where we had head and size was 0, and then what we'll do is we'll try calculating it in such a manner. I initialized one variable called as size, which is initialized to 0. Right now we do not know what's the size till the node is not equal to null. Fine, till the node is not equal to null, keep on going, keep on checking further how many nodes are there till you find that the pointer part, for example, if this is the node, it will have some data, it will have some next pointer, till this goes in a manner where you find data but the pointer portion is null, till you reach that particular place. I guess that's not very clear, so let's erase it. Let's write in a better manner. Fine. So say that for some linked list you were traversing, you had data here, fine, you have next pointer here, and then you had this particular node where again this was the last node, till you encounter this null. Fine, till then you have not stopped in this loop. Fine, you will not stop until you encounter such null. Fine. So basically when I try going like this, what I'll do is I'll keep on traversing, and with each updation I'll keep on updating the pointer to the next node. Fine, and the size would keep on increasing, right? The size would keep on increasing. As the size increases, it will basically lead to every time, for example, I reach here, this becomes 1, fine, then I go further, again the iteration doesn't stop, size would again increment to 2, fine, size becomes 2, say this was head, fine, and head was pointing here, fine. So in this case size becomes 2. As soon as you reach here, the size becomes 2, and then you have reached null, this loop would stop executing, you would return size, the size would come out to be 2. Fine, so this is calc size. In the next video, in the next part, we'll understand about insert last, insert position, and display functions. Fine, so that's pretty much for this video. Now, why I was telling you to comment, because top 3 comments might stand a chance to win the Prep Insta Prime subscription for free, and I'm not joking, we have given giveaways recently, you can go back and check some videos. Alongside that, you can directly follow me on social media handle, my Instagram handle, that is Shuklaji Speaks. There you can directly connect with me, I can directly solve your queries. Alongside that, follow all our social media handles so that you never miss any hiring update. Alongside that, there is a page called as 150 Not Out. Fine. Why did I build it? You'll find the link in the description. These are just 150 questions. Once you have solved them, if you have them on your fingernails, no need to solve lead code 200, 300, 500 questions. No need to do anything apart from these. These are 150 different patterns that I have given you, and this list is free of cost on Prep Insta, so you can simply go ahead and see that out in the description box. You will find the link to it. You simply click it and you can enjoy this list thoroughly. Why am I saying this? Be it Oracle, be it Adobe, be it Mang, be it any product based company, be it any service based company, you can easily crack if you have 150 Not Out on your fingernails. Recently a student texted, and I can show that text to people if you want. She texted that recently she gave an interview and 2 questions were asked in her coding round. Both of them were from this list. Fine. So to that extent, this list can help you out, and this is free of cost, so you can check it out. Alongside that, you can check out the Prep Insta Prime, which can offer you multiple ways of implementing this linked list. Fine. So there you can check that out, and you can use the code Shukla10 if you want to enroll there, because alongside that subscription you'll get 200 plus courses for yourself. So go ahead, check that out. And leaving that apart, the most important thing, whatever knowledge you get here, go ahead, spread it out. That's important. Fine. वीडियो शेयर करना या नहीं करना, बट नॉलेज जरूर शेयर कर देना लोगों से, ठीक है? So with that note, I leave you guys. Keep doing good for others. Good will come back to you. Have a wonderful day ahead.